Yes, yeah, yes, sir. So today, welcome everyone to AI Robotics Club webinar, Woxsen University. So today, I introduce you to the speaker, Mr. Kanakaraju. Mr. Kanakaraju is currently associated as a senior data scientist with a Hyderabad-based AI/ML company known as RoundSqr. Numerous data-driven solutions to difficult business challenges. So, Mr. Kanakaraju did his Bachelor's of Engineering from JNTU, Hyderabad, and has over 6 years of experience in this field. Over to you, sir.
Yeah, thanks, Megha. So, good evening, everyone. Hope everyone is doing well. Yeah, my name is Kanakaraju. I'm a senior data scientist associated with RoundSqr. I have over 6 years of experience. So today I wanted to discuss, or at least to give a fair idea about the introduction to data science. Megha, can you please allow me to share my screen?
Yes, sir. Just a minute.
Yeah, thanks.
Sir, you can share now. Yes.
I hope everyone can see my screen.
Yes, sir.
Megha, can you see my screen?
Yes, sir. We are able to see your screen, sir.
Some response, please.
Yes,
Yes,
sir. We are
Raju, we can
able
see your
to.
screen.
Yeah, sure. Thanks. Thank you. Thank you. Yeah. So today
Sir,
the main
it's
agenda.
probably connectivity issue. Sorry.
Okay. Okay. Sure. So the agenda for today is to give a fair idea about the introduction part, and also walk you through the difference between the AI, ML, and DL. What are those buzzwords and everything, and also the applications in the data science, and the finally with the Q&A. So I'll let me complete the overall part of it, and then I'll give the after completing my slides. I'll allow you to ask me questions so that you can shoot it. So yeah, so today's yeah. So first of all, what is the data science? See, the term data science was coined in 2001. The data science is a broad field of a study, pertaining to the data systems and processes, and it is mainly aimed at maintaining data sets and deriving meaning out of them. The data scientists use a combination of tools, applications like whatever the tools like the the programming languages or the analysis tools or visualization tools and everything, and apply some principles and algorithms on top of the data which was collected as a part of the business problem statement, and will bring out some useful information out of it. So we are living in a data age. So what do I mean by that? So in this data age, it's clear that we have the surplus amount of data. The huge volume of data makes it literally impossible for a human to parse it in a limited time frame, right, or reasonable time frame, I can say. So data is collected from various forms of different sources, and often comes in a very unorganized format, where in this process the data can be missing or it can be incomplete sometimes, and it can be wrong. Maybe there might be typos while, for example, let us say while entering the age of a particular person, instead of entering it as a 22, maybe there might be a typo like triple two. So it can be a, the outlier within the data. So oftentimes we will have to look at the or perform all types of ed on top of it. What I mean by exploratory data analysis, and understanding the data, and making some useful information out of it. Let us say, let us understand, we are collecting a data of a pricing of a used cars. So one feature of a car can be the year it was made, and the other might be the number of miles on that car. So once we clean our data, we know we can bring some useful relationship between the data, and the data becomes more obvious. So one of the main goals of data science is to make explicit practices and procedures to discover and apply many relationships on top of the data, or apply these relationships in the real-time data. Now I have a quick question to all of you. So what are all the different sources that we usually collect the data? Anyone?
Serve from any website or else data which is collected personally, like primary data, or else
Yeah.
data which is have already have in Google or else in any website.
Yes. Correct. So the collection of data involves in two types, like the primary data and the secondary data. So the primary data is collected by connecting the interviews and surveys, and whereas the secondary data is collected using the sensor data or satellite data or web traffic or etc. So coming to the AI versus ML versus DL. So nowadays we can hear a lot of buzz around it, right? About AI, DL, ML. So I just want to make things clear here before we even get into it. So AI, artificial intelligence, so which aims at enabling machines to execute reasoning by replicating the human intelligence. So what do I mean by that? Since the main objective of AI processes is to teach the machines from experience, feeding the right information, and self-correction is crucial here. So AI experts rely on the deep learning and NLP based methods to help machines identify the pattern, the underlying patterns, and get the useful inferences out of it. Coming to the ML, machine learning. So machine learning is a subset of artificial intelligence. That means which systems can automatically learn and improve from experience, like the past data. Giving computers the ability to learn from the data without explicit rules being given by any program. So this particular wing of AI aims at equipping machines with independent learning techniques, so that they don't have to be programmed to do so. Let us say, for example, if I want to write a program to detect or to identify an apple, so I start giving by red, the color should be, the pixel should be red, and so on, and the shape should be in some sort of circular thing, and the depth and everything, right? So what if suddenly I look at the green color apple? So I have to write a lot of rules on top of it, right? So machine learning will help us to the write the features in an efficient way. We don't have to write the handgraph, don't have to write the rules for that. So it will extract those features, so which you will learn if you get into this data science domain in a proper thing. And deep learning is a subset of machine learning, again, which structures the algorithms into multiple layers in order to create a, let us say, artificial neural network. So what does artificial neural network does? It will tries and extract all the features from any given data. Let us say the same example, let us say the apple. So it will tries and extract the features from the whole high level information to granular level information, and out of which then it will be feed forward to a one loss function having those some hidden layers. And with that it will compare with the ground truth, with the actual one, whether it is apple or not, and based on it it will correct itself, and based on the whatever the features that it has extracted, it will narrow down the features, and it will find out the right one. So that's how the artificial neural network will work, and it helps in making the intelligent decisions on its own. So the intuition behind the artificial neural networks are the human brains. So so let us understand how can this data science, AI and ML work together. For example, let us imagine we are building a self-driving car and trying to make it stop at stop signs. So for that we need all three: data science, artificial intelligence, and machine learning. So what is the role of machine learning here? Machine learning is the car should recognize the stop signs using its cameras. So we need to create a data set with million number of street side object photos, or and train an algorithm to recognize which at which it have to stop its signs on them. And the artificial intelligence part is, as soon as the car recognizes stop signs, it should start applying the brakes. So the car should hit the brakes right in time, right? Not too early, not too late. So plus we should mind different road conditions like slippery road, whether it is raining or not, and the various conditions. So this is not, this is an, again, the issue of a control theory. Again, I'm not getting into the details of the control theory, but just understand control theory. It is something that, you know, it which has the control on all the, you know, the mechanical gears or so on. And coming to the data science here, you know, during all these tests, we see sometimes our car doesn't react to the stop signs. By analyzing the test data, whatever we, you know, we perform on top of it, we perform some model performance on top of this test data. We find out that the number of false results depends on the time of a day, or the car tends to miss the stop signs at night. And then we see that most of the training data include objects in the full daylight. So, and now we can add some few nighttime picks and can you know, get back to the learning, right? So that's it. This is all where this ML, AI, DL will connect together. So now that's how the, I told you, right? So the way that the three are, you know, joined together. The thing is, you can't just pick one of the technologies like data science and ML, and data science and ML and go hand in hand. And machines can't learn without the data, and the data science is better done with the ML. As well as we can't use ML for self-learning or you know, the adaptive systems, skipping AI. So AI make devices to that show human-like intelligence. Machine learning allows algorithms to learn from the data. So that's where, you know, all this connected together. So what are the types of learning that we have in this data science domain? I hope I'm not going in a faster pace. So I hope you can understand what I'm saying.
Yes.
So yeah, thanks. So the types of learning are, you know, the supervised, the semi-supervised, and the reinforcement learning, and the unsupervised learning. So what is a supervised learning? So like you can see here, you know, we have a proper data with proper labels, and, you know, we will the input and output will be given as a page, and, you know, the algorithm, whatever the algorithm that comes under the supervised learning, will give you the some sort of a rules, so that you will you will run those rules on top of the object, so that whenever it recognizes the new object and it will apply those rules, if it is falling under those rules, it is following those rules, it will detect that as a particular object, or else the probability will be very less. So where here, you know, the data is balanced, and, you know, the for every input data we have a proper labels. Coming to the supervised learning, I mean, the augmented supervised learning, there is some data with properly annotated, or I can say the labeled data. We can generate much much samples out of those data, like augmenting the data, what we call it as the augmenting data. Let us say I have a picture of, let us say, a remote. So a remote, I have a picture of only the front view. So I can flip it, I can you know, flip it or rotate it, or, you know, I can perform all sorts of transformations. Those are you know, can be seen in real time. So those all transformation I can apply on top of one single image, and I can augment the data. I cannot do few transformations. Let us say, for example, we want to augment the data of a human faces. So we can flip it, but we cannot make the upside down, right, the picture of it, because we can never see any person upside down. We can see only in front view, or we can see it in a flipped view, right? We can say it mirror view. So we have to keep in mind while performing the augmentation techniques, what are the reasonable transformations or the augmentation techniques that we can perform on the data or not. Coming to the semi-supervised learning, so the data will be huge, and only few of them are labeled here. So the rest of are unlabeled. So it is part of supervised and part of unsupervised. So that's why it is called as a semi-supervised. So how we gonna deal with this? You know, this uh, basically you can perform some sort of active learning techniques to get the inference from the unlabeled data based on the, you know, initial training with the labeled data, and with the highest uncertainty we can pull those data, and with the lowest uncertainty we can pseudo label the data. So this again comes into the active learning techniques. I'm not getting into the details of it. Maybe we can have a separate session if you are still interested in the topics that are part of these techniques. So coming to the unsupervised learning or reinforcement learning. So reinforcement learning is, it's the algorithms, get to choose an action in an environment, and it will be rewarded based on the actions that it performs on top of it. Let us say in a gaming section. So there is a 20 levels. So maybe at 8th level I have some bug. So it chooses some environment in the gaming space, and it will performs the actions on top of it, and it will learns by itself by performing the actions, because we will be rewarding it if it is taking the right step to get into the optimized way. We will be rewarding it with a positive number, or else it will be a negative number. So that's how the reinforcement learning will work. So coming to the unsupervised learning, we will be having a data, but we don't know what we have to do with it. There is no chance, or it does not deal with the predictions, but has much more open objective here. So we can reduce the dimensions of the data, or we can cluster the data using the unsupervised techniques, and so on. So the problem statements here are, it can be a regression, classification, clustering. All this comes under the part of it, comes under the classification. I mean the supervised learning part, and part of it comes under the like clustering, comes under the unsupervised learning part, and the few of them where it comes under the semi-supervised learning. So these are all the problem statements that we deal with in our real life in the data science domain. Right from the regression. Regression is like, let us say we want to predict some stocks of a particular thing based on the previous data. So we use the regression because it has to deal with the continuous variables or continuous numbers. Or in the classification, it can be binary class or multi-class classification. What do we mean by classification? Let us, if you consider the previous example, I was talking about the apple example, right? If I give an apple or orange, so the classification between the apple and orange, so it is a discrete number, right? So it deals with the classification. And the clustering, when we don't have a proper output, the prediction, it doesn't, like I said, it doesn't deal with the predictions, right? So it has to group the similar ones to one side, and you can try and understand the underlying patterns involved in the clustering techniques. And there are other techniques where you can use time series forecasting. Let us say the weather forecast, or the stock market forecast, whatever it may be. It depends on the problem context again. So these are all the problem types that were involved in the data science domain. Yeah, coming to the data science life cycle. So I just wanted to give you the whole idea about how this data science life cycle will be, like right from the business understanding to data collection and data preparation and performing EDA on top of it. EDA is nothing but exploratory data analysis, where we explore the data, like how the behavior of the data is, and how what are the statistics of the data, and we will come to one conclusion, and we will model it using uh, the business problem context. Let us say if it is a classification, we will model it to a classification problem, and then we will evaluate the trained model, and then we will deploy the model. And again, if there are any gaps in between the actual one and the predicted one, we will again get into the root cause, where the business understanding, the understanding of the business is maybe different or not. And this is how the data and life cycles has. Like coming to the business understanding is it plays a key role in success of any project. We have all the technology to make our lives easy, but still with the changes and the tremendous changes of the success of any project depends on the quality of the questions asked for a data set. Every domain has a business, but with a set of rules and goals, right? So in order to acquire the correct data, we should be able to understand the business. So asking the questions about data set will help in narrowing down the correct data acquisition. So if you lack in understanding about the business, you will be not asking the right questions, and you won't be taking the right variables, and it eventually it will fail at the main problem solving, like the building the model and whatever it may be. Coming to the data collection, before we begin the project, it is important to understand the various specifications and requirements and priorities of a required budget, right? So you must possess the ability to ask the right questions. So when I say right question, you are here to access or assess if you have a required resource present in terms of people or technology or time, and the deadline that you are going to commit to support the project. And in this phase, you will also need some time frame of a business problem to formulate the initial hypothesis. Let us say I have one problem to solve something else. So I initially be having some business domain knowledge and asking for a few variables. Let us say I'm trying to solve the customer profiling in a banking project. So I should be able to ask for the right data to perform the required problem statement. For example, if I want to collect the data and perform the pre-approved loans or not, let us say I want to do some sort of a customer profiling on the data that I have from a bank, and I want to perform some I'll give some pre-approved loans based on their credit history and the past behavior and the spends and everything. So here I should be asking for a right data, right? So I cannot perform, maybe the bank will be having complete data, but I should be targeting only on a particular data where I can take the right data and perform the analysis that I'm going to do. And when we collect the data preparation is most important here. So what do I mean by data preparation? Data may be not be in a required format every time, because whatever the format that we want to follow as a part of the machine learning pipeline process, that will be different, completely different from their end, because the data they'll collect will be helpful for their application process, but it might be not in a required format. So to perform any analytical step on the data, it needs to be in a certain format, right? So it could also be said that data needs to be cleaned before processing any further. So sometimes data might be missing, or it can be the outlets might be there within the data, and maybe there are more external factors that we have to consider while performing this data preparation techniques. And once we have a proper data and we have prepared the entire data, we will do the exploratory data analysis. Like exploratory data analysis plays an important role in the this stage, because it gives you the proper understanding about the data. So it will give you the summarization of a clean data, and it will help you to understand the structure of it. Are there any anomalies within the data, and any patterns are underlying and that are contributing towards a particular particular output or not, and this everything will be understood when we perform a proper EDA. And coming to the data modeling, so now let us say if it is a classification problem, so we will be having some assumptions for to implement any classification problem. Let's say I want to implement logistic regression or decision tree classifier. We have to understand the assumptions of a particular machine learning algorithm and also the limitations of it, and the same comes with the data. So if you think after performing all those EDA part, if you think this the data is following the assumptions that were followed by this ML, this particular algorithm, then you will pick the data to use this ML algorithm, and you will perform the data modeling, and you will evaluate the model. You will not only stick with the one particular model, but you will come up with different models, and one will be your baseline model, and if the other performs any outperforms the baseline model, then that you will consider that. So you will perform the evaluation metrics. For a classification, there will be some F1 score, precision, recall, as sensitivity, specificity, and there are other metrics that we will consider as a part of a classification metric in terms of model evaluation. And once we think everything is good, and we can proceed for the model deployment. And for here in the model deployment, we have to understand the server behavior, the scaling, and everything. And again, as a part of this model deployment, we will understand whether the performance is good or not, whether it is once we release it into the real world, whether it is performing in the right way or not. And then based on the feedback, then we again go to the business and business understanding if there are many changes in it. If there are any gaps between the understanding of the business, then we will again get into touch base with the business understanding, or else we will come to the model evaluation techniques again. So this slide explains you about the typical the various typical roles that are in the data science domain. So there are 4 verticals basically: the business vertical, data, model building, and model management. So within the business, there will be a roles called business analyst, functional analyst, and domain expert or subject matter expert. And within the data, there will be data analyst, data engineer, data visualization, data architect. And within the model building, here comes the data scientist or the statistician or engineer. What does it mean? Or means the operational research, where you'll have to work for optimization of the problem statement. And again, coming to the model management, it's not about only deploying the model, but understanding, and you have to change the version of it every time, because once you fix the model, it is not going to fix, right? So every time the data will be changing, you will be understanding the data again, you will retrain your model and deploying it. So now the next slide will depicts you the roles, and which roles will come under which vertical. So in this particular ML process in an enterprise slide, you can see the business problem will be nothing but framing the ML problem framing. Basically, you'll try help the formulate the right questions, having the domain knowledge with the domain expert and so on. And coming to the data vertical, it's part of a data collection, data integration, data preparation, and data visualization and analysis. It all comes under the data engineer. So there are a few roles which you can see in the previous slide, but I'm mentioning only one. And again, if after the data collection and everything, you think the data is ready to serve, and then you will perform feature engineering and feature selection, and you'll train a model and do the model evaluation. This is the part of where data analyst or data scientist will do. And again, everything is ready, and you want to deploy your model on some edge device, or on the mobile apps or a web-based application. So nowadays, the most of the mobiles are equipped with some sort of a face detection algorithm. For example, if you turn on your selfie and take it, it will detect it will give you the bounding box around the face, right? So it's basically some sort of a AI has been, or face detector algorithm has been deployed on the edge device. And this is how the entire ML process will be in a nutshell. And if there are any are the business goals met, if you can see in the decision box here, if all the after performing all types of analytical things, and understanding the data and doing EDA and deploying the model, if you still see any gaps between the business, if the business goals are met or not, and based on that, you'll again have to touch base with the all parameters, and maybe you have to relook at the data that you have collected as a part of your training the model and everything. So this is what all about the roles that are involved in the data science, and the process that will be involved as a process of training any model on the data. And now we will look at the applications of the data science. I hope everyone is following. I hope I'm not going much at a faster pace.
No, sir.
Yes, thanks. So one application.
Yes.
So one data science application, one of the data science applications we can talk about is fraud and risk detection. So nowadays you can see a lot of in the earliest applications of a data science, they were in the finance domain. So companies were fed up with the bad debts or losses every year. So however, they had a lot of data, which they have collected as a part of their initial paperwork while sanctioning any loans. So now they decided to bring in the data scientists, or the data analysts, in order to rescue them out of the losses. So over the years, these banking companies learned to divide and conquer via data. For example, performing customer profiling, or based on the past expenditures, they can give you some sort of offers regarding the pre-approved loans, and they can offer you some vehicle loans and so on. These are all comes under the customer profiling, and basically understand, and based on your CIBIL score and all these your past expenditures, they can understand the risk of giving a loan to a particular person or not. Whether if any particular person is chosen at random, whether he's going to will calculate the probability of risk of default. So based on that, they'll give the sanction the loan. And if you can observe, the most reputed companies, for example, let us take ICICI Bank, for example. So this bank, they has been tied up with some proper organizations, and if any person coming from this particular organization will be having a lower interest, because it has calculated the risk of probability, whether the most of the people from this company are going to default or not. And there will be few companies which are not listed in their application, so they'll charge the higher interest rate, because at least they'll cover the initial amount within the few tenure, few months, as a part of their interest. So the next slide is about healthcare. So nowadays, the healthcare sector especially receives, great benefits from the data science application, because especially in terms of medical image analysis. So procedures such as, detecting the tumors, or the artery stenosis, or some sort of venous insufficiency in the veins, and a lot of the application that we can see nowadays. We can see a lot of traction in terms of medical image analysis. So it applies machine learning methods like, content-based medical image indexing, and some sort of a wavelet analysis for solid texture classification. And it basically tries and understand the texture analysis on a MRI images or MRV images. So MRI is nothing but, magnetic resonance imaging, and MRV is a magnetic resonance, venous imaging. Basically, it studies about the veins. Okay. So yeah, so there are, a lot more traction in terms of this healthcare. So this is the major applications have been seen in this healthcare domain. The other is genetics and genomics. So data science applications, also enable an advanced level of treatment applications now, like personalization through research in genetics and genomics. And the goal is to understand the impact of the DNA on our health, and find individual biological connections between genetics and diseases, and drug response to a particular DNA structure. And data science techniques allow integration of different kinds of data with, this genomic data, and in the disease research. For example, if I choose to give some drug, so if I was chosen to give a drug, let us say COVID vaccine or anything, so what are the adverse effects that will be gone on me, will be studied as a part of my DNA structures. So it will observe, it will understand the reactions between this particular drug and disease, and as soon as we acquire this, the reliable personal genome data, we will achieve a deeper understanding of the human DNA. So, and also in terms of drug development, for example, see, the drug discovery process is highly complicated, and it involves many disciplines. For example, there is a great idea back then, they used to take at least 12 years for developing any drug, because they has to make a trials on many people and different sets of people, not only from one part of a people, or one part of a geographical location, or one part of gender, and it has to consider many samples in such a way that it has to be cover all aspects of the regions of persons. So but nowadays it has become better by simulating the data. So data science applications and machine learning algorithms simplify or shorten this process by screening these drug compounds in the prediction of success rate based on the biological factors. For example, it simulates all this the adverse effects of the particular drug on a particular person, and then it will give you the predictions on top of it. Basically, it will give you the future outcomes with high accuracy, so that whether the drug has to be approved or not, and the decision can be made on top of it. Yeah. So internet search. So when we speak about search, we all will think about Google, right? So, but there are many other search engines as well, like Yahoo, Bing, Ask, and then so on. So all these search engines, including Google, make use of data science algorithms to deliver the best results for our search query in a fraction of seconds. So if you, as a matter of fact, Google process more than 20 petabytes of data every day. So basically, for example, if I'm trying to search about the weather today, so it automatically gives me the suggestions based on my past search query, maybe the history, and based on the geographical location, and based on the network that we are connected to the same thing. Maybe if you can ever try and see, let us say there is a Wi-Fi network where 5 people are using, You search for something, and within a very short time, the other people will receive the similar kind of ads that you have searched for. So basically it process a million number of the parameters and the data, and gives you the suggestions. So targeted advertising. So yeah, before I was telling you, right, so based on the past behavior, we will be able to given some sort of suggestions or kind of thing. For example, in a targeted advertising, basically, if you thought about search would have been a biggest or biggest in the data science application. Now in the targeted advertising, it's starting from the display banners on various websites to the digital billboards at the airports. Almost all of them were decided by using the data science algorithms. So this is the reason why digital ads have been able to get a lot higher CTR, which is a call through rate, than the traditional advertisements. Back then we used to have a traditional advertisement, right? And also, if you can see now, the most happening season is now the IPL season, right? So now let us say I'm viewing the IPL match in my mobile with in a Hotstar mobile app. Whatever the ads that I'm looking at between the over to over will be different for me and you, because it actually targets on the geographical location, and also the recent searches that I have made and everything. It considers each and every factor and gives me the customized or personalized ads, so that the CTR will be high, which is a call through rate will be high. That's how it promotes their advertisements. And next is a recommendation engine. So it is also one of the most important applications, where it has a huge traction in the market. So we all use it to the suggestions, right, about similar products on Amazon. They not only help you find the relevant products, but from the billions of products, it will give you the relevant one, and it will give you a proper the user experience. A lot of companies like the uses the recommendation engines. For example, the Netflix. If you are a fresh user, you're joining Netflix as a new user, you will be given the suggestions as a part of the top trending one, and also based on your geographical location, and also within the network, whatever the people were using, watching those movies, and you will be suggested. And when you watch at least a couple of movies in the Netflix, it will suggest you, it will recommend you similar type of a genre, or it will see the how much time you're spending on particular section. So maybe you're forwarding the action scenes, and maybe you're viewing the action scenes and forwarding the songs. It will suggest you the most of the action scenes to in the next as a part of a recommendation. So there can be a lot can be done within the this recommendation engines. And also advanced image recognition. For example, in the Facebook, I mean now it's Meta, but formerly Facebook. So whenever you upload a group of people of your friends, upload a picture, it will ask you to tag the friends, right? So basically, what happens here is it will perform some sort of advanced image recognition on top of it. And the great man behind is Jan Leeken. He's the one who actually bought more traction in terms of computer vision, and he is heading the AI research at Facebook currently, and he is the VP of it. But yeah, so advanced image recognition has become more traction, because whatever that you are trying to look at it now, right from your mobile detecting your faces, and understanding the image, scene context, and everything can be done as a part of this image recognition. And coming to the speech recognition, and you all would know that, like the Google, Apple, and the other like Windows having a Cortana. So these are all our speech recognition products. Like if you say, "Hey Google," and if you aren't in a position to type any message, and your life wouldn't stop, right? But simply speaking out the message, it will be converted into a text. And however, it is not completely solved as of now, because of various external factors. But I don't disappoint you by saying those drawbacks. But we have to understand the limitations of the technology. Yeah, finally in gaming. So gamings are now designed using the machine learning algorithms, which improve themselves as the player moves up to the higher level. For example, I have designed a game around 100 levels. Now there is a bug, or I cannot pass to the 21st level. So I can design or implement some sort of a ML techniques on top of this, where it will try and understand the patterns, and it will solve it based on the previous moves, and the rewards can be applied on top of it, and it will clear all the levels, and directly enter at the 21st level. And that is how the tech giants in the gaming industry like EA Sports, Sony, and Zynga are performing this, making the gaming experience into the next level using the data science. Yeah, so I have a lot more to say, but due to the time constraints, I don't be getting into much details of the each and everything. But yeah, so if you have any questions, please shoot. Sorry if I bored you. I'm hoping I'm not bored you.
Hello everyone. If anybody has any questions, please do ask. You can unmute yourself and ask questions, or you can either raise your hand.
Sir, I have a question.
Yes, please shoot. Sankalp, right? Yes.
Can you tell the difference among data engineering and data analyst and data science and machine learning?
Yeah, so data engineer is is a role where someone builds the data pipeline. For example, I have a huge data, so I have to build a pipeline such that I can the pipeline will be fixed, right? So whatever the data I'm going to get from the huge databases, let us say consider this as a big data problem. So the data engineer will build a pipeline for this to extract the right fields from the databases and provides to the data analyst who is going to perform the analysis on top of the data. And data scientist is someone who tries and understand the performs the feature engineering on top of it. Let us say this data engineer has given around 100 variables, maybe 100 columns or 100 features, we can say. So we have to perform some sort of a feature engineering or feature selection with having a proper understanding of a business domain, and we can extract that. So that is where you differ from the data engineer and the data analyst or data scientist.
Sir, what is the difference between data science and machine learning in precise?
In precise, okay. So machine learning is a subset of a data science. See, basically, you try and understand the data while you implement. For example, if you have a data and you know what to do, so you after performing all the EDA part, and you are performing some machine learning algorithm, which means it will tries and gives you proper predictions on top of it, where the data science is a part of everything, like right from the ML, and it combines the ML, the deep learning, and everything within the data science domain.
Thank you, sir.
Yeah. So any questions?
Sir, I have a doubt, can I?
Yeah, please.
Sir, previously you have said that AI is also helping in the medical science to detect few diseases. If for example, a common fever uh, and a viral fever and a viral infection, which has which has
Symptoms.
similarities between them, then how can it identify what is the exact disease to the person?
See, as a part of doing so, I hope you're talking about the medical image analysis. Is it? Okay.
Yes, sir.
So yeah. So let us say you are dealing with some lung images. Maybe you want to detect whether there is a pneumonia or not. So based on the symptoms that the doctor collects as a part of this while interacting with the patient. For example, you are having some moderate symptoms that might be severe for me, right? So whatever the information will collect as a part of the from the patient will be kept aside, but will not take it as a serious, because like I was telling you, right? So the moderate for you will be severe for me. The severe for me, maybe the light, the someone can take it light, right? So for considering about the medical image analysis now, so we are not saying that we will completely avoid a doctor by predicting something. So we will try and understand. For example, I have built a CNN model on top for classifying whether a patient is having a pneumonia or not. Forget about the class imbalance problem, because in the medical domain we usually have a class imbalance problem, right? So forget about that. Assume that we have a proper balanced data, or we somehow managed to perform some balanced techniques and everything. Now our model has predicted something, right? So we can perform some sort of some deep tailor visualization techniques or some interpretation techniques. What features are contributing towards a particular X-ray image is being classified as a pneumonia or not. So we can understand what are features that are contributing to say particular class is present or not. And we are not avoiding the doctor. We are helping the doctor in terms of in shortlisting those images. So here we have to bother about the false positives. So false positive means, however, we will shortlist. We are not saying with 100% accuracy. We are predicting it. So prediction will be accurate sometimes, inaccurate sometimes. But we are shortlisting the data and giving to the doctor, and our clinician, he will understand based on the prediction that we have given and take the necessary steps. Yeah. I hope I answered your question.
Yes, yes, sir. Thank you, sir.
Thank you. Any questions?
Yes, sir. I think it was what you explained was very elaborate, and most of us understood it really well, sir. So I don't think anybody has any questions as of now. So I'd like to thank you very much, sir, for this session. I think many of us have gotten really good takeaways from this session. Thank you so much.
Thank you. So if in future, if you wanted to, know about a specific topic, do let us know. So maybe we can have a separate session on a particular topic.
Yes, sure, sir. We'll be really glad to have you again.
Yeah,
Thank you so much, sir, for
Thank
such
you.
a
Thanks,
wonderful
everyone.
session. Yes, thank you.